So thank you for staying for my talk. I know I'm between you and beer, so thanks. I appreciate it. It has been a great day, and thank you to the organizer for having me here and for you for listening. I'm here to talk about something called Take On Me. You might know this. This is actually a 1985 music video with really catchy tunes and these wonderful animations. And I just really liked it when it came out. I mean, no, I wasn't even born, but it was really interesting. And what I'm going to talk about is basically not the catchy tunes, because we already have a really good talk about all that. But I'm actually going to talk about the mesmerizing animations and how we can actually try to do something like that on the web. Because basically mesmerizing animations is my life goal. I really enjoy doing these kind of really useless things, like with CSS, JavaScript, and whatever. This doesn't really give me any money yet. So actually I work as a front-end developer at a digital agency called Aerolab. And on the night, I'm actually a protector of useless creativity. Also, I'm a Mozilla Tech speaker and organizer of CSS Conf Argentina. So in case you are interested in eating asado and drinking wine, you can keep an eye on us. Maybe we'll make it next year again. And by the way, my name is actually Maria Evangelina Ferreira Kuzminski, but I thought that was too hard. So what is this anyway? This is an animation technique that has actually 100 years old. It's called rotoscoping. And it basically consists on recording a video, totally common video, and then making draws on it, on each and every frame of the video. It's not necessarily new. I mean, it has 100 years, but it wasn't only used in this Take On Me video by the Norwegian band Aha. It was actually used a lot of times after this because it was kind of popularized in pop culture. So it was also used by Green Day in 2009, and in 2014 by Lily Allen. Also by Paramore 2 years ago with this video Hard Times. And again by Paramore last year with Caught in the Middle. So the way rotoscoping works is the following. We record a video. It's a completely normal video, maybe someone walking around the street, and then we begin to draw on top. And we draw around 15 to 25 images per second. That is a lot. It takes a lot of time, and it's usually just, scratches around. It's not necessarily the best drawing that you will ever make, because basically it doesn't matter. I mean, the idea is to do something like looks really nice. So once you put all those images together, you go from something like this, which looks really what, into something like that looks amazing. And it only took like maybe a month to make, so it's not that bad. The technology right now that we use is basically a tablet, Adobe Photoshop, or perhaps Adobe Premiere. So we use that kind of software to open the video and begin making these kind of animations. So when this video came out 2 years ago, I began wondering if we could actually create something like this on the web, or actually take some ideas. And it made me think again about traditional animation and the relationship on the web. Because if we actually take a look at what is going on right now with animation, we know that we have taken some things from these traditional animations that come from motion pictures and all that. I think the two that are the most important to mention are stop motion and motion graphics. We have these two on the web right now, and they were taken from these traditional animations. If we have a stop motion, it's because someone like Rachel Nabors actually began talking about how we can use sprites to actually create this kind of stop motion and walk cycles. And if we have motion graphics, then we have SVG and JavaScript or CSS, and someone like Chris Cannon, and I don't know if you follow him on CodeBen, but if you don't, you should. He actually thought, okay, maybe we can make animations with SVG like a pixel spinner, because everybody needs that. Yeah? So can we go further? Can we take more traditional animation techniques into the web, into our browser? Can we perhaps do rotoscoping on the web? No, we can't. Why? Well, because basically rotoscoping is such a beautiful art because it's completely handmade. And it takes so much time. It's basically drawing 20 pictures for 1 second. And that beautiful thing about being so artisan is not something that we can take into the browser. But nevertheless, we are not really necessarily trying to make the same thing. We can take this idea of rotoscoping and try to take advantage of it in our browser. So the basic idea of rotoscoping is you get a completely normal video, and over that video, you do something. And the thing with music videos is that even though I love them, they are not really interactive. I mean, not at least the one by Paramore. It's not like you can click it and something different will happen. The video will stop probably, but it's not necessarily wonderful in that way, in interactive way. But since we have our computers, we actually have a lot of interactivity. We have everything that the browser has. We can click on something, we can drag something, we can zoom in, zoom out. We need to take advantage of that because the music video goes rotoscoping, so we can have interactivity. So why I want to talk about this kind of thing. If we take a look at this part of the video, basically we are looking at 3 layers of stuff. First of all, we got the background. The background is in motion, it's these kind of blue and yellow lines. Then we got the two person dancing, and above them we got these draws that basically make what we most commonly know as rotoscoping. But if we look at the behind the scenes, what we see is something like, great, awesome. I mean, they had fun probably, but if you look at it like this, it's like a joke. But in the end, it looks really amazing. So what goes on in the middle is basically removing the background and then adding the animations. So if we want to do something like this, first of all, we need to be able to remove backgrounds. And to remove backgrounds, we can do something called chroma key. Chroma key is what you basically see on behind the scenes in movies, like action movies, like Avengers and all that, where they have a green background and they remove that green background through computer science and all that. They put like spaceships and all that crazy things. So chroma key is not necessarily easy to use or to do, and it takes a lot of processing. Basically, if you want to do it at the moment, perhaps you need software, proprietary software like Adobe Photoshop. In this case, we are going to try to do this in the browser. So we are going to have green or blue background. That's the main chroma key. We never use red because our faces have a tendency to be reddish. So it will take out our faces, and that's not nice. So we usually use green or blue, which are the 2 colors that are not too common in our bodies. And then we need really good light, but no natural light. Natural light is the worst when we work on animations and when we work on these kind of things, because basically the sun is evil. The sun moves, I mean the earth moves around the sun. So the problem with that is that if you are going to take 10 hours to make a video, to make an animation, then you are going to put it all together. Basically, you are going to have different shadows all the time because of the basic daylight, So we don't want natural light. It's something that if you have ever worked on animations and you have software, we usually want this kind of artificial light because it's very consistent. And we need good light. So what I want to work on is basically making chroma key with the user's camera, because that's the important part. That's the most interesting part, where we are actually using the browser. So what we are going to do in order to create this is to first take the user's camera input, and then we are going to copy that into a video tag. Once we got it into a video tag, we are going to copy that input, the streaming, into a canvas. And we are going to process that canvas. And when we process a canvas, what we are going to do is actually remove the green or the blue and show a background image or a background video. So that's the first step. Take the user's camera input. For this, we got get user media. It has been used today by Vitaly. Vitaly got the audio. I'm interested in the video, so I'm going to ask for the video of the user. It will return a promise, and I will copy that content into a video tag. To do that, we take the stream, and you put it into that video. So what you get with a little bit of CSS is something like this. Okay, it works. So you get this pop-up that was in Spanish, but it basically says, will you allow the use of the camera? You say yes, and it works. And you are streaming that video constantly into a video tag. So then we copy that input into a canvas, because in the canvas we can actually process it. So we create the canvas, we can put in an ID, and we basically say, OK, I'm going to do 2D stuff. And we create this kind of function. And this function will take the content of the video from the top left corner into the bottom right corner, and it will take that into the canvas. If we only run this, the problem will be that the canvas will be freeze in the first frame, and the video will keep on running, because it's not refreshing. It's only running once. So what we need to do is we need to be very non-performant at all and set time out with 0. And in this way, we actually call the function all the time, so we are drawing all the time until the user stops the video. So that will keep the canvas updated with a video input. And we will get the same content on the left, the video, and on the right, the canvas. Something like this. So it works. That's my cat. The other one didn't want to show up in the video. So, so it works kind of OK. And basically, what we need now is to process a canvas. So what we are going to do is we're going to remove green or blue. For this, we are getting to the world of pixel manipulation. What we want to do is want to understand a little bit what is a pixel. And I know this is kind of redundant because we are probably all web developers, and it's like our lives are pixels. But let's take a closer look. So if we take a look at a video or even an image, what we mean when we actually think about pixels is the tiniest part that is around an image or around a video. This will be returned in RGB format. So when we take a look at this, what we are actually seeing is the red, the green, and the blue that actually make that purple color. And the RGB format goes from 0 to 255, 0 being completely black, and 255 being the strongest red, the strongest green, and the strongest blue. In this case, we got a lot of red, we got some green, and we got a little bit of blue in order to make that purple. Now there's something else, the alpha channel, that makes something either transparent or opaque. Now in videos in general, we don't have transparency. When you record a video, you record the whole thing. But anyway, you will still get the information of the alpha channel. And the alpha channel will always return 255 because there is no such thing as transparency in videos, unless you change it. So that's the wonderful thing. We can actually wonder, and we can ask if something is green, and if it is green, we can tell the alpha into 0. And that's how we are going to make chroma happen. So first of all, we need to actually find the green pixels. To do this, we are going to create a function that is called findGreen, and we are going to use getImageData. GetImageData will go through all the frames of all the video from the top left corner to the bottom right, and it will save that information in this variable called frame. I did a console log of this variable. I wouldn't recommend you to do this, but let's see what it got. Basically, it got something like this. So it got some data. It got the height, and it got the width of the video. And the data, I don't know if you realize, but it's like a huge array. And I mean 1.2 million items in there. So that's a lot. Where does the number come from? Well, it's basically the width of the video multiplies the height of the video times 4. Because it doesn't only give us the information of one pixel, it gives us information of the layers of that pixels, the RGB and A. So that's all that we are going to get if we console log that information. And if we open it, and open it again, and again, and again, finally we get something interesting. And in this something interesting, what we get is kind of a sequence, which is this 255. This 255 is our alpha value. It's our transparency. So there is no transparency, so we can easily identify where the A value is. And if we can identify that, then that means that we can identify all the other numbers. RGBA, 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 RGBA per 1.2 million. So if we want to know what the first pixel of the very first frame looks like, we actually got the information. It looks like an RGBA of 55 red, 74 green, and 86 blue with 1 of alpha value. So what we need to do is we need to make this wonderful for loop into all that data and find the green pixels. So if we recognize that the green pixels are the ones with the higher value, higher than the red and higher than the blue, what we are going to do is we are going to remove the opacity of that very pixel. So we turn the alpha value, which is the number 3, to 0. And then we return this new data with the transparency pixels. So this kind of works. But it looks really weird. I mean, it looks like it's not working really well. And it isn't. So what is going on in here? Well, I use sunlight. So that's why you don't use sunlight. You get a lot of light on one side and a little bit on the other one. And then suddenly, I don't know if you noticed, my hair is not green, but nevertheless, it's being cut off because some pixels are greenish than others. So we need to actually improve it. And for this, we actually need better light, no natural light. And we also need to remove only if the green value is bigger than 100. This way, we can be sure that what we see is really green and not something brownish. So I waited until the night. I turned on the artificial lights, and I modified and only remove the green if it is bigger than 100. And I get this, which is almost OK. But there is something really wrong going on with my T-shirt. And I know what you're going to say. It's a Harry Potter T-shirt, so it's magical. Yes, but besides that, it's white. And white has a tendency to take in a lot of their surroundings. So it's really not a good idea. So I changed the T-shirt, and I try again. And now we got it working. So this is good. This is what we really, really want. So here comes a live demo. And we'll see how it works. We get this thing right here. I also added a drop-down at the bottom to select if I want to remove the green or the blue. I allow the camera. And hi. So this is in green, and we get green. And we see how the light works. Yeah. So the background, the background you are seeing is the Hogwarts. Thank you. Yay. So you can be in Hogwarts, or you can be in here. And then, 1 second, we can change it to blue. And now, thank you, I can get into Hogwarts like this. It's a really cheap ride, you know? Thank you. So a side note, I obviously have a green wall at home because I really like this stuff and I like to pretend I'm in Hogwarts. Next thing is actually an invisibility cloak. So if we can actually remove the background and put a background image, what if we make the background image the same background that we have without us? So I'm a big Harry Potter fan. You might have noticed. So what I'm going to do is I'm going to open the other demo, invisibility cloak one, and I'm going to take a picture of the stage without me. OK? Straight. OK, the last one we'll have to do. It won't be perfect because we have the screen at the background. But let's see. I will take the picture that I just took. I will put it as a background image. Let's copy the name. And we edit the CSS. So in the CSS, we got this background image here. And what we are going to do is we're going to replace Hogwarts PNG for Windows something Okay, so let's try it. Let's go over here and open this one. We are going to allow the camera. Here I am. I'm not going to work it with green because I don't have anything like huge green. So let's work it with blue. And we need better light. I'm cleaning the microphone, I'm sorry. And since I'm a millennial, I got my phone with me all the time. So we got this solved, you know. Let's see. Come on, you can do it, phone. Can we get more light? Maybe? Yes, maybe not. I can dress with the other thing, but it's not as fun. Let's see. This is my child's dream. I need to go to Hogwarts. So, no, we are not getting the best light, but I got something else. Maybe more bluish. Maybe this will do. Okay, this kind of works. No, I'm sorry, it's not the best light. But yeah, it kind of works. So sometimes it does and sometimes it doesn't. But the interesting thing about that is that when it does work, it's like this wonderful, it's like this wonderful outfit for introverts. Because basically, yeah, I know the feeling. Basically, you disappear for a while. And so you can try it at home. I will show the links later. Well, it's great. And I believe we can actually do something a little bit better. We can do more manipulation because basically, again, we got the browser and all that. So for this, I wanted to take a look at this part of the video, where basically these hard times again, Hayley Williams is dancing in the middle, and she has like 2 copies of herself also dancing, but in pink. I'm not going to dance, thank God. I got Taylor Swift that will do for me. So I'm going to take this video input, and that will be the source. I will copy it, and I will remove the background, and then I will triplicate Taylor Swift. And to triplicate Taylor Swift, what we basically do is create more canvases. With the magic of CSS, we position them one next to the other one. And we copy into the frame number 2 and number 3 the same information from number 1, because it's what we're actually looking for is the background removed and nothing else. And then we need to turn the other 2 into pinkish versions. So for this, what we are going to do is we are going to find out the pixels that weren't removed. So all the pixels that were removed were turned into 0 for the alpha. And all the pixels that weren't, that means the else will be turned into pink. So in order to get something pinkish, what I'm going to do is I'm going to put a red value of 200 and a blue value of 200. So that will give me something pinkish, and that will give me something like this. I also added a kind of, it's really beautiful. I also added a kind of translate and, a transform to make the other 2 a little shorter, and it makes it a little bit more interesting. And again, we got all CSS for us, so we can actually work a lot with transforms and all that. And you can also make it even more interesting if you put backgrounds of kittens. And you can actually got like whatever you fancy in the internet and put it on there because it will work. So maybe it doesn't make sense, but it looks wonderful. So yeah, this is like the essence of rotoscoping. I mean, it's not handmade, it's not really this artisan, but it's really nice to actually be able to work on this. And again, I could be dancing with the background. I'm just not really into that yet. And it has endless possibilities. And the wonderful thing is that it actually runs in your browser with JavaScript. I mean, I was like 15 years old making really silly videos with a stop motion and even green screen. And I remember like having to find a license for Adobe Premiere and all that, and it was like complicated. And in here, it's like there is no software required. All you need is, good lighting, but that's basically it. You can run it in your software in your browser, and you can do whatever you want with it. So I will kind of keep doing this kind of useless thing. I hope you find it interesting. I will share with you the links. beware with the third link. The third link is the online version of this green screen. So you can have a lot of fun with that, but I wouldn't recommend you open it in your phone because it might crash. I mean, it's 1.2 million pixels all around there. I'm not responsible if it crashes, but you can take a look at it. Thank you.